Oh man, what lesson is this? 72, 2, right? 70, 72, 2. We got more about logs. Let's call it that. More about logs. We're going to cover rules 3, 4, and 5 today. If you did that exploration, it started with this problem right here, and it said that 32 can be broken up into 4 times 8. So that problem turned into the log base 2 of 4 times 8. They had you split it up into 2 parts, log 2 of 4, and they wanted you to add that to the log 2 of 8. This here answer was 2. That answer there was 3. 2 plus 3 is 5, which is the answer for the original problem, because 32 can be written as 2 to the 5th. So it if you did that exploration, you discovered how one of the rules is going to work for logarithms. And that is that we can pretty much pull apart any composite number and look at its factors, and we can analyze the logarithm of those factors in little pieces and add up all of the totals together. And that's pretty much what we did there just then. Let me give you that rule first, and then let's talk about what we're actually doing, how we're making math simpler. People keep saying, can I do that on my calculator? I'm like, yes, but I can do it without a calculator, which means I'm smarter than you are. And I want you to be smart like me, right? Of course. So here's rule number 3. Rule number 3 is the product property for logarithms. I can take a bigger number, break it down into its factors, and then evaluate the log of that base for each number separately. It may be more convenient to break a big number up into smaller pieces and evaluate the logs and then just add those back together. And as you can see here, what it does is it takes what is basically a multiplication problem into some sort of addition. This is the power of logarithms. It's going to take a harder problem, it's going to break it down into smaller pieces and make multiplying turn into adding. This is the way the slide rule works. If you want to watch, there's a number file video on slide rules, an electric slide rule that a guy has in his basement or something. Bonus points if you write me up how that thing works. Okay, let me demonstrate this really quickly. We take something like this. We know that when we were trying to simplify these things, we did some addition, right, with these exponents. We write it as 1 base to the 2 plus 3 power. And that's basically what we do with logarithms. Maybe the problem is log base 10 of some big number, 100,000. We can just split that 100,000 into, let's say, 100 and 1,000. And then evaluate each part separately. No, this isn't a hard problem. I'm just doing it for demonstration here, because it's already base 10. Base 10, or sorry, 100 expressed in base 10 is 10 squared. So this problem ends up being 2. And 1,000 in base 10 is just 10 to the 3rd. So this problem here becomes 3. So the answer to the original problem there of log base 10 of 100,000 is 5. I can split it up into easier pieces. If I wanted to, I could even split this up into, that's 10 times 10 times 10 times 10 times 10, and add up all of those little problems together. I'd have log base 10 of 10 plus log base 10 of 10 dot dot dot. Log base 10 of 10 is 1. Log base 10 of 10 is 1. I did that 5 times. 1 plus 1 plus 1 plus 1 plus 1 is not 1 plus 1 plus 1. It's 5. It's 5. No calculator necessary for that. So the product property says split up a big number into pieces, into its factors, into smaller factors at least, and then add the results of those logarithm problems. I'll show you where this is going to come in handy. Is when we don't have a way, when the problem is written originally, of doing it. I'm actually going to do this problem, this rule backwards. We can go and start here and work our way back to that. And that's what this first example is going to do. Log base 10 of 25 plus log base 10 of 4. You're kind of tempted to get out your calculator and do this and add those two numbers, but that would be stupid. Let me show you why. Because if I back up m and n and I just multiply them together, this rule says that this turns into 25 times 4, which that's 100. And so that's equal to, well, I can do that. 10 to the what power equals 100? 2. All right, that equals 2. I couldn't get to it directly because I don't have a way of expressing 25 as 10 to the power of very cleanly, or 4 as 10 to the power very cleanly. But if I use this rule and I take 25 times 4 is 100, I can squish it together into one problem and it gets really, really simple. Show you another one. Maybe we do the log base 3 of 63. Okay, now in one of the examples they give you a little bit of information. They say, let's give you that log base 3 of 7 is approximately 1.7712. Dudes like Euler used to have to look this up in a log table, or he had those things memorized, but people had tables, they had to go look these things up. So that there would be a given. Now I can see that I'm thinking 69 is 9 times 7, and 9 is very 3-ish. So I could rewrite this as log base 3 of 9 times 7, which the rule says I can break up into log base 3 of 9 and log base 3 of 7. Log base 3 of 9, 3 to the what power equals 9? Log base 3 of 9 is 2. And we have here that log base 3 of 7 is given to us as 1.7712. We add those together, 3.7712 approximately. And if you double check on your calculator, take log base 3 of 63, or you go log 63 over log 2, or ln 63 over ln 2, or over ln 3, you'll get about that same answer. Okay, so that was given something. Given a little bit of information, we can figure out something we have no way of doing. The easy way, show you one more here. You take something like log 60, we can find out some of the information about this answer, and then we would need a little bit extra help. So this is base 10 because it just says log, so that's the common logarithm. And I'm going to break 60 down into 6 times 10. So I'm going to have log base 10 is 6 plus log base 10 of 10. Log base 10 of 10 is 1. And then I need this information here, which the book gives as approximately 0.7782. Calculator would get that too, and so then we just add, and so plus 1 means 1 plus 0.7782 for the log of 60. You can double check on your calculator that 10 to the 1.7782 is about 60. Anyway, that is the first rule, or rule number 3, the product property. I'm going to clear the board and we'll put up the next one. Right, we got quotient property. I wrote x's and y's instead of m's and m's. It doesn't matter. If I can rewrite a number as a fraction, I can even take a number like 5 and turn it into 10 over 2 if I wanted to. Same thing. I can split up the numerator and the denominator. Any numerator is going to be a positive value. Any denominator is going to be a negative value, or a plus and minus here. And what this division rule, or the quotient property, does is it turns division into a subtraction problem. Same way that if we took the number 10 to the 5th over 10 to the 2, the quick way of doing that was to go 10 to the 5 minus 2 and get 10 to the 3rd. See, it's like canceling out, right? I'm canceling a couple of them out by just subtracting. This is the same type of rule. They take division and turn it into a subtraction problem because logarithms deal with the rules for exponents. So let's take up, hey, those are the same points I had there in my book. Let's take the log base 10 of 400. Okay? If I want to split it up, I just have to think of another way of writing this. Minus log 4. I guess that's the actual problem. I was thinking, how am I going to do this? This creepy way. All right, this says I can work this problem backwards and put it as one thing rather than two. Jacqueline's here, everybody. So this turns into a 400 over 4, which is the same thing as the log of 100. This is base 10, so that means 10 to the power of what equals 100, and the answer was 2. I couldn't do that there, or I couldn't do it there, but I can do it there because it's that, which equals this. Okay, how about a couple more examples with this rule? Log base 4 of 6. Now, in this problem, they say, I'm going to give you something here, a bit of information that you might be able to use. 2.7925-ish, and log 4 of 8 equals 1.5. Exactly. Okay, so you think how 48 and 8 are going to jive together to make 6? You should. We can just make this into 48 eighths. That's equivalent to 6. And then this rule says we can split that up and do some subtraction. That is the log base 4 of 48 minus the log base 4 of 8. So we're going to have this minus that will be our answer. And that will match what that would be if you did it on your calculator. Am I talking loud enough? Okay. Probably need to go back 10 seconds before I erase this. Just in a hurry. Last one uses natural logs, but remember that equals log base e. And so we had a rule the other day that ln of e to the 1 should equal 1, because log base e to the 1 must equal 1. That's the way those things work. So if we say an ln and an e together, basically like saying log 10 of 10, okay? It's the same deal. The bases match, the answer is 1. That was from a long time ago. The problem in the book is this. The natural log of e to the 4th over 3, given that the natural log of 3 is about 1.09, blah, 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 blah. So, break this up. We can have the natural log of e to the 4th minus natural log 3. This part right here is saying log base e of e to the 4th. Remember how I worked over here? If it's 1 is 1. So this part equals 4. And then they gave us this part here, 1.0986. You could do that. I'm not going to do that math for you. That's ridiculous. That's just subtraction. Come on. So this is the beauty of it. Turns a division problem or a difficult division problem into subtraction, which is much better. Bam! There was actually, in fact, an instance right in here of the 5th rule. The 5th rule. The 5th rule actually says I can pull down any kind of power of a number down into the front because I'm just going to be taking multiples of something anyway. So say I could rewrite this one as 4 times log e to the e. That part's 1. This is 4 times 1 is 4, which was the answer. So we've got a fifth rule here. Rule number 5, the power property. And this is my favorite of them all. If I got a power sitting out there, I can just pull it out to the front. Log base b of some number that's already written to a power equals that power times log base b of 8. Simplifies the problem. I take that whole exponent thing and just put it out in the front. So let me show you why this works. Log base 10, common log of 1,000. That equals, let's rewrite that 1,000 as 10 to the third, right? 10 to the third. This says I can go 3 times log 10, which is 1. So I'm looking at 3 times 1 is 3 for my answer. Well, that jives with this at the beginning. This is log 10 of 1,000. The answer was 3. So if I can rewrite it and just get the base 10 and the base here 10 to match, then there's my answer. That was one of the previous rules. Show you another one without base 10. Let's go log base 3 of 81 squared. 81 squared is a big number. Yeah, we got rules for how to square numbers, but why? Why if we don't have to, right? So this rule says I'm going to pull that 2 down into the front. I know that this is basically 81 times 81, which we already had a rule for that. That's the multiplication rule, the product rule. And the product rule says let's do each of these separately, right? And if I have 2 of them and they're the same, that's just multiplying by 2. Let me say that again. If I add 2 of them, like let's make it 3 times 3, and I want to do that twice. 3 times 3 is 6. That's the same thing as 3 times 3 is 9. I could just do this twice. I could say let's find the answer for 3 and let's find the answer for 3 and we'll add them together. I didn't do that very well, did I? Okay. 2 times log base 3 of 81. The 2 comes down the front. I got to figure out this problem here. This problem here, 81 is 3 to the 4th power. Wait. Yeah, it's 3 to the 4th power. This right here is a 4. 4 times 2 is 8. I could even keep going. I could say, well, 81 is 3 to the 4th. And now I can pull this 4 down out in front. I can say 4 times 2 times log base 3 of 3. That's equal to 1. I got 4 times 2 times 1 equals 8. That is so awesome. I love this rule. It is so tight. Now let's throw several of these rules together into one big old fat problem. Let's do natural log 5e over x. And we want to split it up, tear it apart into all its pieces, and rewrite this thing into 3 smaller problems. Up here we got a product rule, so we can rip that apart to natural log 5 plus natural log e, and then this division part will be a minus natural log x. Think about this natural log x part. It's minus, right? Why can't I just take this and put it back up here? That would be natural log of x, like to the negative x, which means it's a reciprocal, and that's why that x is sitting down there in the denominator. Ain't that cool? It is cool. Oh, and this problem had a squared up there, so I can just pull that down into the front and say it's twice of whatever that business is. How you like that, Smalls? Put that on your hat and wear it, because I can't say other things on a video for children that I probably want to say. Last thing, this deals with earthquakes and stuff because earthquakes are on a logarithmic scale. you have a problem, it says there was a 7.1 magnitude earthquake, and you throw that into the equation m equals 2/3 log of the amount of energy that thing releases to the 10 to the 11.8. That's a really confusing equation with all that stuff in there, and that's really wonky too. But if I throw in that 7.1 here, I can start to do some math. I can multiply by 2/3 for starters, by 3/2, sorry, to get that to move to the other side. So I'm going to leave all this business here and just do this one bit at a time. Second thing is I can rip this thing apart into two pieces. I can rip this apart into the log of e minus the log of 10 to the 11.8. Now this is log base 10. So I got the base and the base that match. This whole business over here is just 11.8. That allows me to free it up and move it over to the other side. 3/2 of 7.1. Now add on to both sides 11.8. So I just whipped that out on my calculator. Can we get it to focus? There we go. Okay, so, gotta hit the equal sign. 22.45. 22.45 equals log base 10 of e, and I just changed the form there. This is equivalent to 10 to the power of, that's how much energy. Right there, just put it in an exponential form and I'm done. D-O-N, done. This is a sample problem. It wasn't the problem out of the book. Yeah. So there you go. These are 3 new rules for logarithms. Practice them. Get used to moving things around and pulling things apart. And be a lot of stuff you can do without your calculator, or just the calculator to do a simple thing. It turns multiplication into addition, and it turns division into subtraction. You're welcome.